covalent bonding now. Coordinates. This is the second type of bonding. So what are we supposed to know about this coordinate covalent bonding? Number one, it also involves sharing of electrons. Are you listening?
Yes, sir.
Yes, sir.
One of the participants owns the electron. One of the participants owns the electrons. Owns the electron. Owns the electron. Or the electrons. While the other are sharing from it. So in this case now, it is different from normal covalent, ordinary covalent, because in ordinary covalent bonding, the participants are sharing electrons equally. Maybe 1, 1, 2, 2, 3, 3. You get the point. But in coordinate covalent bonding, there is sharing of electrons, but not in the what? Equal proportion. One of the participants owns the electron, while the other is just coming to share from the electrons. You get the point. So, and this is often found in species with lone pair of electrons. Species with what? Lone pair of electrons. Are you getting my point? So what are examples of species with lone pair of electrons? E.g., we talk about H2O, water. Water has lone pair of electron, NH3. Now, because these substances that have lone pair of electron, if you are drawing the structure of water, water is like this. Can you see that? H2O. I hope you can see what I'm doing.
Yes, sir.
So water has two lone pairs of electron. So, and if you look at ammonia, ammonia is like this. Ammonia has one lone pair of electron. You can see that. Now, because they have lone pair of electrons, they can be involved in what? Coordinate covalent bonding. For example, when H2O is bonding with H+, how is it going to be? The H2O is like this. Sorry. The H2O is like this, with this pair of electrons. Plus, H+ is like this. This one has lost electron originally. It doesn't have any electron, and it wants to be duplex. So it's going to share from the electron of this one. So, and then it's going to come into it and form something like this. Any problem? We can see that the lone pair of electrons are like this. Are we together? So this one is coming to share with it. Can you see that? So that will lead to the formation of what? A. O is like this. You have one H this way. You have one H this way. You have another H like this with a plus. You get the point? And you have one lone pair of electron. Can you see this formation? Hello? Are you there?
Yes, sir. Yes,
Yes,
sir.
sir.
So this is then giving us this, right? This way. With a plus charge up. Now this is called ozonium ion, H3O plus. So H3O plus is called ozonium ion, or sometimes they call it hydrozonium ion or hydronium ion. This compound, which is called ozonium or hydrozonium, or what? Hydronium ion. It undergoes what? Dative or coordinate covalent bonding. Another name for this type of bonding is called what? Dative bonding. That owns the electron is called the what? Donor electron. The donor atom, I mean. The donor atom. So that's the donor atom. Is that clear?
Yes, sir.
Good. So apart from H3O plus that undergoes coordinate covalent bonding, another another molecule that undergoes coordinate covalent bonding is ammonium ion. So ammonium ion is NH4 plus, H3O plus. The two of them are undergoing what? Dative bonding. I've explained how this one undergoes dative bonding. Abi?
Yes, sir.
Now I want to quickly explain how NH4 undergoes dative bonding. Now it is formed from NH3. Don't forget for dative bonding, one of the participants must have lone pair of electrons. Is that clear? So the NH3 now has lone pair of electrons. It is binding with what? H plus. So it's going to form dative bonding. How is that? We know that NH3 from what we've done before is like this. Isn't it? So it has one lone pair of electron. I hope you are listening. Then plus the H plus. This one doesn't have anything and it wants to be stable. So it will come and share electron with this. So it will now become so at the end, you are going to have it this way. I hope it's clear.
Yes, sir.
Many a time you see it this way. The arrow will be pointing up. So if this arrow that is pointing up is telling us that this nitrogen is in donor atom. Because the nitrogen is what? The owner of the electron. So this is our what? Donor atom. So NH4 plus undergoes which type of bonding? Coordinate, covalent,
Covalent or bond or
dative.
dative.
Thank you. So I hope that is clear. Now apart from this, you realize that this coordinate covalent bonding, we are having one of the species or the molecules which is having lone pair of electron. So any molecule that has lone pair of electron in the formation of dative bonding, we call it the what? The Lewis base. Is a Lewis base. or we call it what? Ilatoman quinone. It's a Lewis base or a ligand. Ligand, because I'll talk about ligand, yeah, soonest. So those ones that have lone pair of electrons are what? Ligands or what? Lewis base. Now I've given two major examples of compounds that undergo dative bonding. Please, are you following? Now apart
Yes,
from
sir.
these two, there are a group of compounds, we call them complex ions. Complex ions also undergo dative bonding. Complex what? Ions. So how do you identify complex ions generally? Complex ions have transition metals attached to what? Ligands. Transition metals attached to what? Ligands. I hope you are listening. I've told you
Yes,
what
sir.
ligands are now. What did I call ligands? L stands for what? Ligands. Ligands are Lewis bases. And Lewis bases used to have what? Lone pair of electrons. Are you getting it?
Yes, sir.
So the Tm there stands for what? Transition metals. Am I communicating? So
Yes,
when
Yes,
you
sir.
sir.
have transition metals attached to ligands, example of ligands, e.g., you have NH3, right? And then you have H2O. These ones are two common ones that we've talked about. Abi? Apart from this, we have several other what's it called, like Cn, cyanide ion. Am I communicating? Cl negative, etc. So far they have lone pair of electrons. We say they are what? Transition. I mean they are what? Ligands or Lewis base. How that's led? Transition
Yes, sir.
metals. Examples of transition metals are the first from 21 to 30. Scandium, titanium, right? Are we together?
Yes, sir.
Vanadium,
Yes, sir.
chromium, iron. All those elements from 21 to 30. These are transition metals. Are we together? Copper, zinc, right? Now, since you have identified them, whenever you see any element that is made up of a transition metal and it has ligand attached with a charge, that's a complex ion and is most likely going to be form coordinate covalent bonding. For example, Cu attached to what? H2O. H2O. Are we together? And H2O. And another what? H2O. All this one this way with a charge of what? 2 plus. Are you listening? So
Yes, sir.
this one is a special type of what? Transition. Is a complex ion because it's the middle here. Copper is a transition metal. Attached to it are the what? Ligands or the Lewis acid or Lewis bases because they have lone pair of electrons. Water used to have lone pair of electrons. So this can be represented as Cu into bracket what? H2O in 4 places. Everything with a charge of 2 plus. Does that make sense, please?
Yes, sir.
Now this compound is called what? Copper 2 tetra aqua, right? Ion. Copper
So
2.
why is there 2 plus above the equation?
Yes, it has a charge of what? 2 plus. Well, for now, don't let me belabor you with it. They will not tell you about the charges. But what you should know is that most of these so far it is an ion, it's always going to have a charge. Okay? So this 2 plus simply implies that it has lost 2 electrons. That's just a simple interpretation, but it is more than that, right? In implication. So however, what we are actually talking about here is that we can identify that this compound is a complex ion because of the transition metals and the ligands attached, right? So the number of, okay, let me give another example. Another common example here is this common compound called hexacyanoferrite ion. So it's another complex ions, and we know complex ions undergoes dative bonding. So let me give you that quickly. Fe, that is ion abi, attached to what? Cn, 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 1 2 3 4 5, and another Cn. Don't mind the way I drew it, but it's just SHA-6. Let me restructure this one with a charge of what? 3 negative. So this one is called hexacyanoferrite 3 ion. Now you can see that what we have in the middle here is a transition metal, right? And this Cn attached, they are ligands. So it makes it a transition metal. It makes it a complex ion. So this complex ion can be written as Fe. Please, I hope I'm speaking sense.
Yes,
Yes,
sir.
sir.
Okay. So this one is giving us Fe, Cn into the bracket of 6. Everything into the charge of what? 3 negative. So this is called hexacyanoferrite 3 ion. Is that okay now?
Yes,
So
sir.
these compounds, these ions, whenever you see any complex ion that is having a transition metal and a ligand, definitely the kind of bond that will be connecting them is what? Dative bonding. Is that clear now?
Yes, sir.
Yes, sir.